Good morning, class. So, the lesson is about Module 4, Measurement of Airspeed. So, it is connected doon sa Module 3 natin sa Basic Aerodynamics. We discuss sa Module 3 yung Bernoulli's equation, compressible Bernoulli's equation or energy equation, hydrostatic equation, equation of state, equation for compressible flow, and equation for incompressible flow to summarize the equation we discussed in Module 3. This time, the application of the compressible flow equations and incompressible flow equation in the measurement of airspeed. So pag sinabi na measurement of airspeed, automatically kadikit niya yung word na pitot-static system or pitot tube. Pitot-static tube. Yung pitot-static tube or pitot tube, it is really important when it comes to flying. No, kasi pag nakasara yung pitot tube mo, wala kang mababasang reading or lalabas na reading dun sa cockpit instrument mo. So, yun yung kung mapapansin nyo is remove before flight na tinatanggal some parts of the fuselage or wing or the tail of the aircraft. So again, pitot-static system is the standard device for airspeed measurement. So sa airspeed measurement, we have the P sub O. So yung P sub O na to is total pressure or stagnation pressure. Yung P na yan is the static pressure or the ambient pressure. Pag sinabing P sub O is not sea level, no? Total pressure or total stagnation pressure. Ibig sabihin, yung velocity mo comes to zero or isentropically to zero velocity yung velocity sa ating total pressure. At low speed, so we have incompressible flow equations. We make use the Bernoulli's equation to obtain the velocity from pressures and density. If you can remember the Bernoulli's equation, di ba, we have P sub 1 plus 1 half rho V sub 1 squared is equal to P sub 2 plus 1 half rho V sub 2 squared. So, in application doon sa pitot-static system na kung saan the stagnant pressure or total pressure has a zero velocity, kaya mapapansin nyo here is walang velocity na itong part na to. Kasi nga, isentropically to zero yung flow mo at total pressure. That's why we have P plus 1 half rho V squared is equal to P sub O. Yung P sub O na yan is total pressure. Manipulating the formula, we can have velocity is equal to square root of 2 times P sub O minus P over density. Okay, yan yung formula natin to get the velocity from pressures and density of the pitot-static system. So again, yung P na yan, the P and some other book that is P sub S, no? It depends kung paano nyo lalagyan ng subscript. So yung P na yan is the stationary pressure, static pressure, or the ambient pressure. Pag sinabing P sub S, pressure static, yun yung pressure at that altitude or pressure nung layer na yon, no? At certain layer or pressure na nag-a-act doon sa skin ng isang eroplano. So the static pressure decreases with increased altitude. So basically, the static pressure is yung kinocompute natin from the module 2. Okay, sa gradient layers equations natin. This one naman, the 1 half rho V squared, no? Some books identified or symbol ito na Q, small q, ibig sabihin that is dynamic pressure. So pag sinabing dynamic pressure, merong air in motion and has energy because it possesses a density, which is mass per unit volume, that exerts pressure on any object in its path. So 1 half rho v squared is dynamic pressure, notation with a q, small q. P sub O or P sub T is the total pressure. Total pressure, stagnation pressure, stagnant pressure, no? Reservoir pressure, no? Pwede natin gamitin tong equation na to sa reservoir. So, as long as zero velocity or approximately zero, we can call this P sub O or P sub T, which means that is stagnant pressure or total pressure. So ano bibig sabihin yan? It is dynamic pressure plus the static pressure. No? So combination of static and dynamic is equal to Pitot pressure. So yun yung isang tawag sa kanya. Total pressure, Pitot tube pressure, uh, pressure measured by the Pitot tube. So again, total pressure P sub T is equal to dynamic pressure Q and static pressure PS, no? So yan yung other symbols nung part na to. So if total pressure is constant along a streamline flow, therefore if static pressure decreases, then dynamic pressure increases and vice versa. Air that is flowing horizontally flows from high pressure to low pressure. The highest speed occurs where the pressure is lowest, and the lowest speed is where the pressure is highest. So be mindful that when the static pressure decreases, the dynamic pressure increases. No? Kasi nga, di ba, if you can remember, the Bernoulli's equation states that pressure plus 1 half rho v squared is equal to constant. So that's why if static pressure increases, dynamic pressure must decrease. Okay? Total pressure at a given point in a flow is that pressure that will exist if the flow were slowed down isentropically to zero velocity. Okay, that is the total pressure. Slow down isentropically to zero velocity. So sample problem. A Pitot tube is mounted in the test section of low-speed subsonic wind tunnel. The flow in the test section has a velocity, static pressure, and temperature of 150 miles per hour, 1 atm, and 700 degrees Fahrenheit respectively. Calculate the pressure measured by the Pitot tube. So this one, no, yung given is meron kang open subsonic wind tunnel, walang reservoir. So ibig sabihin itong inlet na to maybe is open sa atmospheric, and then meron kang exit, and meron kang embedded Pitot tube sa test section. So station 1, station 2, station 3 ang una mo agad maiisip. And then if you read again the questions, no, lahat ng given is about sa test section, which is station 2. Okay? Sa station 2, located ang Pitot tube. Hindi ibig sabihin nun, no, kung ano yung pressure sa station 2, yun ang pressure sa Pitot tube. No? Reminded, no, kailangan lagi nyo isipin, no, yung Pitot tube measure the total pressure. Okay? Dahil total pressure ang mini-measure niya, kailangan natin gamitin ang equation na to. Okay. So kung gagamitin natin to, no, to determine the measure the pressure measured by the Pitot tube, kailangan natin ng static, no, static pressure, density, and velocity. So yung static pressure natin nag-a-act sa test section. So ang kailangan nating velocity sa test section. So given naman, no, we have 150 miles per hour. Pressure static is 1 atm. Temperature 70 degrees Fahrenheit plus 460, that is 530 Rankine. So determining the formula, wala pa tayong density. However, no, from the equation of state, meron tayong pressure and temperature. So, yung calculation natin to get the density sa test section, we have 1 atm times 2116.8 pounds per square foot over 1 atm, 1716 pound foot per slug per run-kind times 530 run-kind. So, maka-cancel out dito is the run-kind and also the pounds. And this ATM, 1 atmospheric. So, meron kang natirang slug per cubic foot. So, ang density natin is 0.00232748337 slug per cubic foot store A. No, you can practice naman during or habang sinusundan nyo itong recording video na to. So, dito sa equation natin, kumpleto na. No? So, P sub 2 plus 1 half rho V squared sub 2 is equal to P sub T. No? Tinama ko lang yung subscripts. So, P sub T, the total pressure or pressure measured by the Pitot tube, we have 1 atm times 2116.8 PSF over 1 atm. And then, plus 1 half stored A density slug per cubic foot and velocity 150 miles per hour times 88 over 60 feet per seconds per mile per hour squared. So, ang total pressure natin or pressure measured by the Pitot tube is 2,173.125109 pounds per square foot. So, paano naging pounds square foot yan? This one is directly pounds per square foot. Ito naman, slug, no? Meron kang slug per cubic foot. Ito is feet squared per square foot, per square second, sorry. And then, maka-cancel out yung isa rito sa square foot mo and sa cube, feet cube. And then, slug feet per second squared is equal sa pounds. So, that's why pounds per square foot. Okay. So, continue. In measuring the airspeed of the aircraft, meron tayong true airspeed, equivalent airspeed, and calibrated airspeed, and also indicated airspeed. So, yung mga airspeed na yun is merong differences, lalo na when it comes to incompressible and compressible. So, to measure the aircraft true airspeed, KS, at incompressible velocity, gagamitin lang natin yung derived formula natin. Now, which is square root of 2 times P sub O minus P over density. Yun yung V-true natin. Bakit siya tinawag na V-true or true airspeed? Simply, ginamit niya yung mga reference or ambient properties ng air. Okay, dito, yung static pressure and yung density is the true density or the static density nung isang property. However, there is no simple device for measuring density. Thus, airplane instruments are calibrated assuming sea level density. So, kung yun ang true airspeed mo, meron din tayong tinatawag na equivalent airspeed or V sub E or EAS, equivalent airspeed. V sub E is equal to square root of 2 times P sub O minus P over density. Yung P sub O dito is the pressure measured by the Pitot tube. This one naman is the static pressure or the ambient pressure kung saan lumilipad yung aeroplano. And the density is based sa sea level. No, yung S na yan is sea level. So, if nalilito kayo, you can use SL. So, meaning that is sea level. So, true airspeed, ang base density mo is the static density or yung ambient density. Pag sinabing equivalent airspeed, ang base density mo is sea level. Okay, yun yung difference nung dalawa. So, the actual speed of the airplane relative to undisturbed air surrounding the airplane is referred to as the true airspeed. True airspeed is equal to the equivalent airspeed divided by the square root of the relative density or the density ratio. So yung density ratio na yan is symbol sigma na kung saan density, static density over density at sea level. So one way no to get the true airspeed of the aircraft is that pag alam mo na equivalent airspeed and alam mo ang density ratio, you can use this formula. So again, that symbol is sigma. Okay? So manipulating this formula, pwede natin tong itabi. The square root of sigma, pwede nating itabi sa true airspeed para makuha naman ang equivalent airspeed. So equivalent airspeed is equal to square root of density static over density at sea level. Okay? Wait lang guys. Okay? So sorry, may charge lang tayo guys. So yun nga, no? Meron tayong symbol sigma. You can use this formula to get it's either velocity true or true airspeed or the equivalent airspeed. So in fact, equivalent airspeed is more useful to pilot since equivalent stall speed is independent of altitude while true stall speed is not. No? This is because aerodynamic forces are proportional to dynamic pressure, not velocity. At the same time, no, velocity, equivalent airspeed, you have the same Q at any altitude. Kasi nga, naka-density base at sea level siya. So if ever lumilipad ka ng 50 meter per second at any altitude, pag given mo or lumilipad ka ng 50 meter per second, iisa lang yung value ng dynamic pressure mo. Or, yeah, iisa lang yung magiging value ng dynamic pressure when it comes to this formula. Unlike dun sa true velocity or true airspeed. And then meron ditong notes, the reader should observe that at sea level, where sigma is equal to 1.0, the true airspeed and the equivalent airspeed are the same as long as the flow is incompressible. Kasi nga, pag lumilipad ka at sea level, tapos ang reading is true airspeed, syempre sea level yung density. So that's why, sa equivalent airspeed, dahil naka-base siya at any altitude at sea level, meron kang sigma na 1.0. Sample. The altimeter on a low-speed Piper Aztec reads 8,000 feet. A pitot tube mounted on the wingtip measures a pressure of 1,650 pounds per square foot. If the outside air temperature is 500 degree Rankine, what is the true velocity of the airplane and what is the equivalent airspeed? So low speed Piper Aztec, ibig sabihin incompressible flow, reads 8,000 feet. So yung 8,000 feet na yan is altimeter. Ibig sabihin, yung 8,000 feet na yan is pressure altitude. Ang makukuha mo lang dyan is the pressure at 8,000 feet. No, pwede mong gamitin yung pressure at 8,000 feet. Meron kang outside air temperature na 500 degree Rankine. Okay, again, ang equation to be used is ang equation natin, no, which is this one to get the V true and the equivalent airspeed. So dito sa equation na to get the V true, kailangan natin ng delta P or difference in pressure and density. Sa given, wala tayong density. So kailangan muna natin kunin. First step is the gradient layer equations. Okay, we have T is equal to T sub O plus lapse rate times the height. We have 519 plus negative 0.003566 Rankine per feet times 8,000 feet. We have 490.472 Rankine. No? Getting the pressure at 8,000 feet, we have 2116.8 pounds per square foot times 490.472 Rankine over 519 Rankine raised to 5.26. So, ang pressure at 8,000 feet is 1572.281553 pounds per square foot. Store A, and that is our static pressure. No, mind you again, guys, yung pressure na nakuha natin sa 8,000 feet is the ambient pressure, which means yung ang na-read no ng eroplano in terms of static. So, that is your static pressure. Next is getting your density. With the equation of state, we have density is equal to pressure over RT. And then we have pressure, the 1572.281553 pounds per square foot. The gas constant, 1716 foot-pound per slug per Rankine and 500 Rankine no, as given sa atin na outside air temperature. So, cancel out ang Rankine. Cancel out ang pounds. We have slug per cubic foot. So, we have density 0.001832495982 slug per cubic foot. No, I hope same numbers yung sa inyo. So, store B natin sa ating calculator, we have this equation to get the V through. Square root of 2 times total pressure minus static pressure over density. So, total pressure is given. Static pressure is we already computed at store A. And we have density na-compute natin. The outside air density. So we have the true velocity or true airspeed 291.2430291 feet per second. So paano naging feet per second yung dimensions na yan? Simply square root down ng pounds per square foot. Ito naman, we have feet cube per slug. So, yung slug nga is equal to pound for second squared over foot. So, mawawala yung slug, cancel ang pounds. Feet squared, and this is cube, may natirang feet. And then we have square root of feet squared per second squared, and that is feet per second. Okay. So, sa equivalent airspeed naman, ang pinagkaiba lang is that base siya sa density sea level. So, same parameter dun sa ating numerator. Sa denominator is 0.002377 slug per cubic foot. So, ang equivalent airspeed natin is 255.71868859 feet per second. And this one naman is yung another formula na diniscuss natin. So, equivalent airspeed is equal to V through square root of density over density at sea level. So, V through 291.2430291 feet per second. That is our V through. Square root of store B over sea level, 0.002377. So, same number ang makukuha nyo no, kung ano man ang gamitin yung formula dun sa dalawa. Okay? So, I hope same tayo nang nakukuha ngayon. Next, at subsonic compressible velocities naman. So, yun lang yung incompressible. No? Paano naman pag compressible? So, ito yung mas mahabang formula, which is the compressible Bernoulli's equation or the energy equation. So, the true airspeed can be deduced from the isentropic Mach relation if you can remember kung paano natin to derive. Galing yan sa CPT plus V squared over 2 is equal to CPT sub O. Okay? So, some rearrangement or manipulating the formula we can have this equation. So, paano natin nakuha yan? Simply, no, inalis lang natin tong exponent na to, nilipat natin sa P sub O over P sub P. So, we have this parameter. Next na nilipat natin is yung 1. Okay, nilipat natin sa kabilang side ng equation. Kaya naging negative 1, bracket. So, bakit nagkaroon ng bracket? Simply kasi, no, kasama ng m squared yung k minus 1 over 2. So, nilipat natin sila, yung negative 1 and exponent, minultiply natin both sides by 2, no, by 2 over k minus 1. So, meron kang 2 rito and k minus 1. And the m squared is simply what? Tama. Velocity of the object over speed of sound. So, iniwan natin yung velocity dito and stay dito ang A or speed of sound. However, no, yung Pitot static system nga or Pitot tube is a measure, no, mini-measure niya yung pressure difference. Laging may stagnant pressure and static pressure. So, hindi siya nakadepende sa pressure ratio. So, some manipulation ng formula na to, we can have this type of equation. No? So, sa B through velocity natin, meron tayong B squared is equal to 2A squared over K minus 1 bracket quantity P sub O minus P over P static plus 1 raised to K minus 1 over K minus 1 bracket. So, nagtataka kayo paano naging ganito kahaba yung P sub O over P. Simply, nag-minus 1 plus 1 ka lang. No? Kung naglagay ka ng minus 1 plus 1 dito, yung minus 1 mo is para makakuha ka ng pressure difference. So, yung simply, yung minus 1 is magbe-base dito sa denominator natin, no? So, magiging P over P. So, P sub O over P minus P over P plus 1. So, same denominator na P and negative P yung taas. That's why naging P sub O minus P over P plus 1. So, kung mag-input ka ng any number dito, tapos in-input mo yung value na nilagay mo sa P sub O dito and P dito, isa lang ang kakalabasan. Okay, pinakita lang dito na kailangan pressure difference kasi nga airspeed measurement ang kinukuha natin or Pitot static system. Anyways, kung sa problem naman ang binigay is P sub O or total pressure na and hinanap yung T, kahit hindi ka na magganitong formula, pwede mong idiretso dito. Okay? Next, yan, sample problem. A Pitot tube is mounted in the test section of a high-speed subsonic wind tunnel. So, high-speed subsonic wind tunnel, compressible flow. The pressure and temperature of the airflow are 1 atm, 270 Kelvin respectively. If the flow velocity is 250 meter per second, what is the pressure measured by the Pitot tube? So again, pressure measured by the Pitot tube naman. That is the total pressure. So, pwede nyo i-post muna and isipin nyo kung paano sinasagutan. Okay? So, paano ba ito sasagutan? Simply analyze natin yung problem. Meron kang pressure and temperature of the airflow. So, ibig sabihin, yan yung static or outside pressure and temperature ng Pitot tube. Kung saan man located or yan, located siya sa test section. So, ibig sabihin, yung 1 atm and 270 Kelvin as the properties ng air sa test section. Meron kang flow velocity, which is definitely at the test section also. So, from the equation, kung ang hinahanap natin is this one of total pressure, pwede mong gamitin to. Okay? Or pwede mong gamitin, dahil total pressure, pwede mong gamitin naman yung P sub O. No, depende sa formula na gagamitin mo, pero iisa lang ang magiging kakalabasan niyan. So, I think ang ginamit dito is, yung P sub O. This one. Kinuha yung Mach number, kinuha ang total pressure. So, drawing ka ng free body diagram to determine where located the Pitot tube is, and then determine the energy or anong equation yung gagamitin mo, determine your equation. So, again, no, nagsimula lahat sa energy equation. And kailangan magamit natin tong equation of isentropic flow relationship. So, pinakita lang dito kung paano dinerive before ito. So, meron nga galing sa CPTO is equal to CPT plus B squared over 2. No? Multiplying both sides by 1 over CPT, we have ratio TO over T is equal to 1 plus B squared over 2 CPT. However, CP is equal to KR over K minus 1. That's why meron dyang K minus 1 over 2 times B squared over KRT. And KRT is what? A squared. So A squared, V over A is Mach number. Okay. And then yung equation na dinerive natin, no, i-relate lang natin sa isentropic flow properties or relationship. So getting the Mach number, we have 250 meter per second over square root of 1.4 times 287.08 Newton meter kilogram mass per Kelvin and times 270 Kelvin. So, ang cancellation ng units, una dito sa square root, we have Newton, which means kilogram mass meter per second squared. Cancel out ang kilogram mass. Next is Kelvin. Okay, so natira is meter squared, second squared sa loob ng square root sign, and nilabas meter per second na cancel out sa velocity. So, ang Mach number natin is 0.7589141,319 store A. So, using the isentropic flow relation, we have P sub O is 1.46460736 atmosphere, no? Ang given is 180 M, 1 atmospheric value. So, kailangan, English units, we have Pascal. So, 101,325 Pascal. So, 148,401.348 Pascal yung sagot. No? Para makuha. Next is airspeed measurement. In application, aircraft instruments are calibrated assuming sea level, speed of sound and pressure, AS and PS, thus the calibrated airspeed is this one. No, same equation. However, no, yung subscript mo is calibrated. Yung kanina is true airspeed. This time, calibrated airspeed. Okay? So, pag sinabing calibrated airspeed, it is based dun sa sea level, speed of sound, and pressure. Okay? Pero same equation lang din. Believe it or not, this relation reduces to equivalent airspeed relation at low velocity. Ibig sabihin, pag sinabi ng problem, we can use the equivalent airspeed properties or relation to this equation. Pero dito lang sa pressure difference natin. Thus, CAS also has the benefit of providing a stall speed which is independent of altitude. No, kasi yung speed of sound based sa temperature. This one naman based sa density, based sa pressure, sea level. So maybe that's why it can be reduced as the equivalent airspeed or based sa density. Pero however, it is calibrated airspeed. No, which is assuming sea level at speed of sound and sea level at pressure. And airspeed measurement for supersonic aircraft, no, narinig nyo na yan, the Rayleigh Pitot tube formula. So, supersonic speed, the Pitot tube is complicated by the presence of shockwave in front of the tube. So again, this is the total pressure before the shockwave. This one, total pressure after the shockwave. So, pwede nating makuha yung total pressure after the shockwave doon sa ating Pitot tube using the Rayleigh Pitot tube formula. This relation can be used to calibrate a Mach meter. One final note, it has been assumed thus far that the pitot-static system correctly reads both the total and static pressure. In practice, this is not always true. As a result, even after calibration, there may be sensor position errors in the measured airspeed. Thus, the indicated airspeed IAS, which is displayed on the cockpit instrument, may differ from both EAS and KAS. So, dun sa cockpit, meron kang, I think, 4 airspeed, the indicated, which is the indication dun sa mismong instrument. Indicated airspeed ang tawag. And then we have equivalent airspeed, calibrated airspeed, and the true airspeed. So, yun yung airspeed measurement when it comes to calculation. Pero yung apat na yun, no, merong correction. So, meron tayong tinatawag na airspeed correction. The actual airspeed instrument aboard airplanes are calibrated to read true at all Mach numbers under standard sea level condition, provided no instrument or static pressure source errors present. To obtain airspeed from an imperfect airspeed instrument operating under non-standard condition requires that the corresponding errors be accounted for. So, ang una nga is the indicated airspeed. It is airspeed uncorrected for position error. However, corrected doon sa instrument error. Okay, una is the indicated airspeed uncorrected for position error and corrected siya sa instrument error. Okay, so indicated airspeed AIS. So it is uncorrected for airspeed system error or the position error, but corrected for instrument error. Okay? B sub I yung abbreviation niya. So yung B sub I MD is simply from your sa subsonic or airspeed nyo, if matatakal nyo, is indicated airspeed at minimum drag, MD. Next naman is the calibrated airspeed. So, indicated airspeed corrected for position error is calibrated airspeed. So, ibig sabihin, yung calibrated airspeed is airspeed corrected for position error and instrument error na. So, it is indicated airspeed corrected for position or airspeed system error. So, this one is the basic conversion ng isang piloto when it comes to KS and CAS. No? Hindi siya applicable dun sa kaninang ginawa nating equation. So, example, kunyari ang given, you have calibrated airspeed 80 knots at 7,000 feet density altitude. So, you are flying 80 knots plus the density altitude in 1,000. So, that is 7 feet. So, 7 times 1.5% is equal to 80 plus 10.5% of 80. That is true airspeed, 88.4 knots. So, if you are flying at calibrated airspeed 80 knots, meron kang true airspeed na 88.4 knots. So, yung density altitude in thousands na yan is simply in terms of feet. Okay. Next naman, we have, di ba, meron na tayong indicated and then calibrated. Next is equivalent airspeed. So, equivalent airspeed is the calibrated airspeed corrected for adiabatic compressible flow at a particular altitude becomes equivalent airspeed. Okay, so it is calibrated airspeed na corrected na for adiabatic compressible flow. And okay, next naman dito is the relationship no ng Mach number and altitude on calibrated airspeed. So if you have no calibrated airspeed, meron kang constant Mach number, assuming you have constant 0.7 Mach number. Okay? With increasing altitude, no, makikita nyo, this one is sea level. With increasing altitude, decreasing ang kanyang calibrated airspeed when it comes to constant Mach number. Okay, ganun binabasa yan. To further simplify this graph, I have this, no? Una is below 36,090 feet. Anong ibig sabihin yan? At troposphere or gradient layer. So, below troposphere, meron kang calibrated true airspeed and Mach number. Ito, increasing speed. This one, increasing altitude. At constant calibrated airspeed, no, increasing height, increasing ang true airspeed mo and Mach number. Pag constant naman ang true airspeed, with increasing height, the calibrated airspeed is decreasing, Mach number is increasing. Pag constant ang Mach number, calibrated and true airspeed is decreasing with increasing height. Para naman sa troposphere or above 36,090 feet, at constant Mach number, increasing ang true airspeed and Mach number. Para dito naman sa constant true airspeed and Mach number, we have decreasing calibrated airspeed with increased altitude. Okay? So, meron tayong apat na airspeed. Huwag kakalimutan ng true airspeed. Meron tayong indicated. Again, indicated airspeed. It is airspeed uncorrected for position error but corrected for instrument error. Pangalawa is the calibrated airspeed. It is indicated airspeed corrected for position error. Equivalent airspeed is calibrated airspeed when corrected for adiabatic compressible flow. And the last is the true airspeed of the aircraft. So, true airspeed is the actual airspeed ng aircraft. Yun lang definition nun. So, sample, an airspeed indicator on an airplane is calibrated in accordance with the incompressible flow assumption. While flying at sea level, the indicator shows 500 miles per hour. What is the true airspeed? Assume standard atmospheric condition. So, sinabi dito what is the true airspeed? However, the indicator shows 500 miles per hour. Ibig sabihin, compressible flow. No? Dahil compressible flow siya, ang gagamitin natin equation is pang-compressible na airspeed. So, this one, the true airspeed formula natin. No? Ito yung gagamitin natin. However, binigay na parameter is that the calibrated in accordance with the incompressible flow assumption. Okay? So, ang unang step is that kailangan natin kunin yung P sub T minus P or the difference in pressure when it comes to incompressible flow assumption. Okay? So, meron tayong 1/2 rho V squared. And then that is 1/2 times 0.002377 slug per cubic foot times 500 times 88 over 60 squared. Okay, that is 639.148 pound per square foot. Bakit natin kinuha again when it comes to incompressible? Kasi sinabi ng problem. Okay, pag meron na tayo niyan, input natin dun sa ating compressible flow equation. No, simply, ang pinanggalingan lang netong equation na to, no, kung nalilito kayo, di ba? If you can remember, the true airspeed, merong A dito. So, isinama ko lang dito sa m squared. Pinapakita ko lang kung paano mag-manipulate ng formula. Pero, kung gusto nyong gawin or gayahin or gamitin yung equation kanina na pinakita, which is b sub true, okay lang din naman, no? Pero dito, kailangan nyo kasing matutunan kung paano mag-manipulate ng formula. Manipulate ng formula. Okay? So, equate lang natin dito sa ating equation lahat ng values given. Okay? Meron tayong Mach squared na 0.3915096262. So, squaring both sides, no, square natin, square root, para matanggal yung squared. So, that is m is equal to 0.62957073007. Store B. And getting the V through is simply Mach number times speed of sound. And we have velocity 698.6787923 feet per second. So, you can practice the dimensional analysis dito sa part na to, and you can read this dimensional analysis also. Okay, you can pause if naguguluhan kayo para ma-analyze nyo yung problem. Next is a high-speed subsonic Boeing 707 airliner is flying at pressure altitude of 12 km. A pitot tube on the vertical tail measure a pressure of 2.96 times 10 raised to 4 Newton per square meter at what Mach numbers the airplane flying. So, una nating nabasa is that is high-speed subsonic. Pangalawa, pressure altitude. No? So, pressure altitude na 12 km, ibig sabihin nasa isothermal region siya. Pitot tube, that is P sub T, 2.96 times 10 raised to 4 Newton per square meter. So, paano natin kukunin yung sagot dyan, no? With the Mach number? Simply getting the pressure at 12,000 feet. So, dito, no, we know na temperature at 11 is 216.66 Kelvin. So, kinuha natin yung pressure. That is 22,606.82333 Newton per square meter. Store A. So, bakit natin kailangan store A? Kasi, kailangan natin gamitin, no, yung equation at 12 km or at isothermal region. No? That is P sub 12 over P sub 11 is equal to E raised to G over RT times H2 minus H1. Okay? So, inequate ko lang to, no, yung mga nakuha nating given. So, meron tayong pressure at 12,000 na 19308.23278 Newton per square meter store B. And then we can use the formula na, no? Another formula na kung saan given naman ang pitot tube. Nakuha nyo guys kung paano mag-manipulate. So, kailangan yung practicein kung paano mag-manipulate ng isang formula. So, nakita nyo, this is different approach naman, no? Pero same thing pa rin yan. Galing lang din yan sa energy equation. So, input lang natin yung formula. We have the Mach number M is equal to 0.805706127. Okay? So, that's I think that's the end of the module 4. See you next week for module 5 and 6. Okay, you can ask me a question sa messenger ko if ever may nalilito or meron akong nasabing incorrect doon sa solution process. Thank you. Bye guys.